The broadcast is now starting. All attendees are in listen-only mode.
Hello and welcome to our July webinar, All Things Solar for Affordable Multifamily. My name is Matthew Mills and I'm an Energy Advisor for the Multifamily Energy Program. And with me is Stephen Gribble from our training partner organization, AEA, Association for Energy Affordability. The intention of this webinar is to give a high-level overview of the trends regarding solar and multifamily projects in Oregon, and to have Stephen dive into some of the technical details involved in incorporating solar into a new construction or existing building project. ORMEP seeks to assist in the combination of energy efficiency and on-site energy production, so we aim to also share a few local resources along with a case study organization that has successfully integrated solar into their core building principles. Thank you for attending, and let's get started. A few housekeeping notes and instructions on how to use GoToWebinar. Today's webinar will be recorded and available on the program website within a few days. All attendees are currently in listen-only mode. If you'd like to ask a question, please ask the question in the question box on the GoToWebinar panel, and we'll do our best to answer questions in the order that they are received. At the end of the training, we will open the audio line for questions. In order to participate in the discussion at that time, please enter your audio pin located in the center panel of your screen and raise your hand in the meeting panel and we can unmute you. As a reminder, this webinar is part of a series of trainings geared toward supporting current multifamily energy program participants and multifamily professionals. We will cover topics relevant to both existing buildings and new construction projects. Our next webinar, All Electric New Construction, will be held on September 26th at noon. You can register for it on our program website, and be sure to also register for our monthly newsletter to stay updated on future trainings that will be announced. We have a pretty full agenda for this presentation, as you can see, which will cover the following topics. Solar in Oregon, site assessment and selection, additional solar considerations, methods for reducing project costs and improving a return on investment, best practice, and a case study. We'll aim to be done with this presentation in about 45 to 50 minutes and allow 10 to 15 minutes for questions and discussions afterwards. Before we begin, let's review a few of the learning objectives that we have today. First, we want to discuss what makes a good multifamily solar project and what goes into that consideration. We want to gain a better understanding of what the financial landscape to support this work looks like. We'll see a successful new construction projects that were able to incorporate large PV installations and energy efficiency measures into their designs. And finally, we want to generally increase attendees' comfort level around solar on multifamily dwellings. So let's get started by discussing solar in Oregon. So as ORMEP and solar, we currently incentivize energy efficiency upgrades on new construction and existing building projects. Fortunately for the projects that come through us for funding, our team is dedicated to helping support the integration of solar onto any and all projects that seek on-site energy generation. We view energy efficiency and solar as going hand in hand and believe the current rapid uptake of solar will continue to thrive. As always, we will provide project support as well as providing resources for learning about solar design, public policy decisions, emergent technology updates, etc. We also look forward to continuing to provide relevant trainings like this one. Additionally, we can serve as a conduit to local solar incentive programs and are happy to make that connection for any interested party. One major example of how ORMEP ties well into solar is that buildings pursuing the whole building pathway will ultimately have an energy model that projects how much energy will be consumed by the site on an annual basis. A solar contractor would then be able to use that information along with site data from either the plans or a remote sensing tool, think of fancy Google Earth, to come up with a solar PV design based off of the roof structure that generates the building's current or future energy demand. In short, we aim to maximize the impact of solar by maximizing the energy efficiency of the building. While it's less common now than it has been in years past, I believe it's valuable to review why solar is an effective strategy in Oregon. First, solar works in Oregon. This is a fact. There's a misconception that because Portland area is notorious for its cloudy and rainy winters, that solar is not a viable energy production option, but this is not true. Oregon in its entirety gets plenty of sunlight over the course of a year and has valuable net metering policies and political support that make the investment lucrative for the purchaser and the tenants. There are many residential, commercial, and utility scale solar projects in Oregon that prove the power the solar market has here. Next, the cost of solar continues to decrease. There's been a dramatic decrease in costs associated with solar over the last 10 years, reaching a current value that is close to 60% lower than it was in 2008. This has to do with the production scale manufacturing of materials, reduction of soft costs associated with installation, and the existence of hardy financial incentives. This has made solar installation cheaper and easier than ever. Next, Oregon has political support for solar, which means that there are long-term and short-term goals and policies that positively impact the access to solar. This takes the form of our Renewable Portfolio Standard, RPS solar carve-out, net metering and interconnection policies, and previously the state renewable energy tax credit. Additionally, we have organizations like Energy Trust of Oregon that take massive steps to promote the affordability and reliability of the solar market. And finally, if done correctly, solar can massively benefit the occupants who may have previously suffered from huge energy burdens when living elsewhere. When working on affordable housing, we care to positively impact the people we worked for and not just do things that look good. Solar is a great way to do both. So now we want to dive into the solar goals, Oregon solar goals. So Oregon prides itself on being supportive of renewable energy production, mainly highlighted through our large hydroelectric projects, but also from our uptake of renewable energy in the form of solar and wind. In March of 2016, Oregon adopted its noteworthy Renewable Portfolio Standard that requires 50% of our electricity to come from renewable sources by 2040. In addition to that, Oregon has a solar carve-out that mandates that 8% of electricity provided by electric utilities come from specifically solar. Things like this really boost the uptake of solar and drives the perception that solar is a normalized method of producing electricity on a large scale. Next, while Oregon has a robust code as is, in late 2017, Governor Kate Brown released an Executive Order 17-20, which addressed climate change concerns and mandated furthering building goals and standards within the next few years. One of these goals is that all commercial construction is to be built solar ready by October 1st, 2022. This is not to mandate the installation of solar on these projects, but rather to ensure that solar remains a feasible option on any and all newly constructed buildings. And to take that further, in December 2018, Oregon Housing and Community Services revised the project development manual to require that all buildings that are taking advantage of OHCS funding sources will build all new buildings and substantial rehabilitations to be solar ready and EV ready. While you can find the specific details in the PDM in the Sustainable Development Standards section, I'll go over a general overview now. So this new PDM update applies to all projects submitting fund applications on or after January 1st, 2019, and they must meet the following applicability requirements. The project is 3 or more attached dwelling units, it is new construction or substantial rehabilitation, and they're receiving or will receive OHCS funding. Now, for the requirements of the Solar Ready section, they must first conduct a feasibility assessment, develop a Solar Ready design concept for the building and or buildings, generate an estimation of initial costs and potential financial incentives, have a preliminary solar design assumptions and goals, and provide a service and fee proposal for the solar consultation and applicable work. Or, as an alternative approach, OHCS has approved that complying with Energy Trust of Oregon's Solar or Solar Ready incentive program will be regarded as having fulfilled the intent of the OHCS Solar Ready requirement. Energy Trust of Oregon, who we'll talk about again later, has a robust solar program that provides a resource of guideline standards and trusted solar contractors. OHCS finds that the Energy Trust requirements for both solar and solar ready to meet the OHCS solar ready requirements and encourage all projects to interact with Energy Trust to build solar ready and seek incentives for doing so. So I'll hand it over to Stephen for the site assessment and selection section.
Hi everyone, thanks for your attendance. My name is Stephen Gribble, and I have roughly a decade of experience in the solar industry, encompassing a multitude of different roles and types of projects ranging from single-family off-grid housing to grid-tied affordable multifamily systems and even to large commercial off-site arrays. I currently work as part of the program administration team for California's Solar on Multifamily Affordable Housing program, as well as our low-income weatherization PV program where I provide technical assistance for affordable multifamily building owners and developers interested in putting solar on their buildings. Like Matthew said, through the course of this presentation, I generally want to increase all of our attendees' comfort levels with incorporating solar on existing and new construction affordable multifamily buildings. And to that end, I'd like for this to be an interactive presentation. So if you have questions throughout this, please enter them into the chat box, and Matthew and I will do our best to answer them. Depending on the type of question, we may hold it to a section break or answer it at the end of the Q&A period at the end. We're going to start by reviewing who the potential solar team members on a typical project might be, what types of buildings work well for multifamily solar electricity, and talk about how those determinations are made. So the actual makeup of a team will vary from project to project depending on the size and scope of the project and whether or not the system is being installed in the context of some form of major rehabilitation or standalone project or a new construction development. Since we're talking about affordable multifamilies, I thought I would use a LIHTC funded project to kind of set the stage. So in a larger low-income housing tax credit funded project, the project team might include the owner and the developer, a finance team including a lender and a tax credit investor, an architect who is responsible for project management and setting the design criteria, along with a general contractor who will manage the project, which might include mechanical, electrical, and plumbing engineers who handle those design components. You could have a solar integrator responsible for coordinating the structure of the deal and ensuring that all of the available funding sources are being leveraged, as well as the actual solar provider who is responsible for, as they say, slapping the glass, which is installing the panels, even though they're actually typically made of a polycarbonate rather than a glass, as well as an energy consultant to ensure that the low-income housing tax credit energy efficiency requirements are being met. Whereas on a smaller standalone project, you might only have the owner, developer of the building, and the solar provider who will handle all of those things in-house or somewhere in between the two, depending on the size and scope of your project. You can really put solar on nearly any building, but low-rise apartments tend to be the ideal form factor. As buildings get taller, the amount of usable roof space relative to the amount of electrical load at a building decreases. Mid and high-rise buildings tend to have more common areas and interior corridors that require lighting and space conditioning, and roof space is often in those buildings used to situate mechanical equipment, so there's less free and open space. The higher common area loads coupled with less usable roof space generally means that a smaller portion of the building's electrical load can be offset by the PV photovoltaics. However, if a property has parking on site, that's potentially an excellent opportunity to expand the system size by installing solar on the carports. You get the added benefit of an added or improved covered parking amenity for your residents as well. Just to kind of like put this into terms, if you, for example, have a very simple square building that's 1 story tall and has 1,000 feet of conditioned space, you potentially have 1,000 square feet of usable roof space. If you take that exact same building and stretch it to make it 10 stories tall, you now have a building with 10,000 square feet of conditioned space with the same potential 1,000 square feet of usable roof space. So using that example, you can see that as buildings get taller, the design considerations change a bit. It doesn't mean it's not feasible, just the approach is a little bit different. And that example that I just mentioned, a carport mounted system might be a really sensible path forward. We generally want to locate our panels in places that are not impacted by shading and obstructions. Shading is ultimately the enemy of a productive and cost-effective solar system. In urban environments, shading can come from lots of places. It could be trees, as shown in the graphic. It could be adjacent buildings that are taller than your array might be, or even parts of your own building. In an ideal world, you'd be siting your system in such a way that it's not negatively impacted by shading, but the world isn't ideal, and that's not always an option. So there are some methods that we can mitigate shading. In those cases, we might use what's known as a microinverter, a DC optimizer. This allows the system to operate more effectively in shaded conditions. Traditional inverters operate much the same way like an old string of Christmas lights used to work, where if one light, or in this case a panel, is burned out or shaded, it'll negatively impact the performance of the rest of the lights or array. Whereas microinverters and DC optimizers allow each panel to operate independently, which can be really useful in installations that might be subject to some degree of shading. Obstructions such as roof vents and mechanical equipment can limit the ways in which we're able to lay the system out. So we want to be cognizant of their existence and avoid those areas when we're doing our layout if possible. The following are the typical steps that a solar team will take in analyzing your property to help design an effective solar system. These aren't steps that you need to internalize or perform yourself. Rather, I just want to present a full picture of what the process looks like to help build your familiarity and comfort with the process as a whole. Every solar project is going to include some kind of site assessment to make feasibility determinations. For smaller apartments and simpler systems, a solar provider can typically do enough of the preliminary feasibility and design work using the fancy Google Maps that Matt mentioned earlier to present you with a proposal before really maybe even setting foot on the site. Whereas for a larger apartment with more complex needs, it will probably require an in-person assessment up front to provide you with at least a proposal. So for more complex systems, the site assessment would typically be performed up front, whereas on smaller systems, it might be performed even after you're in contract. Regardless of where in the process it occurs, an in-depth site inspection will be performed to confirm the assumptions and existing conditions of the building. That inspection typically includes 4 pieces: a general site inspection to help familiarize the team with the building site, an electrical inspection to help determine if the existing electrical infrastructure is sufficient and to plan the electrical components of the system. If the system is to be roof mounted, a rooftop inspection will look at the condition of the roof area, the shading, and to determine the location of any potential obstructions that will limit or impact how your team can lay the system out. It'll also include a structural inspection to ensure that the planned system will be designed in such a way as to not negatively impact the structural integrity of the building. The point of the general site inspection really is just to familiarize the team with the general layout of the site. A design team wants to be able to virtually visit the site through photos so they can note the location of trees, overhead power lines, other potential safety hazards when they're creating their safety plans, as well as to be able to give context to the rest of the design and to better be able to locate and specify equipment. The purpose of the electrical inspection is to determine how and where the solar system will be interconnected to the building's electrical infrastructure and ultimately to the utility grid. Oftentimes, the installer can use the existing main panel to interconnect the system for smaller systems, but on larger apartments, there will typically be additional considerations that need to be factored into the final design or upgrades to the electrical infrastructure that might be necessary to accommodate a large array. For especially large sites and those with complex installations and interconnection requirements, it's sometimes advisable to commission an electrical engineer to survey the electrical infrastructure and develop an interconnection plan. If your building is one of those, your solar provider will definitely be able to tell you that this is necessary and help coordinate it. Whatever the specifics are, it is important for the installer to have a robust understanding of the electrical conditions at the site so that the proper planning and steps can be taken to ensure a smooth installation and continued long-term operation. This piece obviously only applies if the installation is to occur on your building's rooftop rather than on top of carports or some other structure. The purpose of the rooftop inspection is to help inform the layout of the solar panels and ensure that the roof is in good enough condition so as not to cause any unaccounted for issues. This portion of the inspection will ensure that the final design doesn't locate any panels in areas that are shaded or to identify shaded areas that need tree trimming or over vents or near other rooftop obstructions. The rooftop inspection will also help your contractor fine-tune their model and present you with an accurate reporting of how much power the system is actually capable of generating over the course of a year. Solar panels are surprisingly light, so much so that you can pick them up with one hand. This means that the structural inspection is typically more about ensuring that a design is created to ensure that any lift created by wind or other forces doesn't pull the panels off of the structure rather than overloading the structure. Although in an older building with longer spans and spacing and areas that potentially have snow loads, it does need to be considered. In an ideal world, the designer would have access to structural as-built plans for the building, but this typically is not the case for older buildings. So someone will need to conduct a survey to determine the size, spacing, and orientation of structural members. If the panels are going to be installed on a pitched portion of the roof, they will always be mechanically fastened to the structure. If the panels are going to be installed on a flat roof, they can either be ballasted, which is a system using weights like sandbags or cinder blocks to hold the panels to the roof, or they can be mechanically fastened there as well. Each method has pluses and minuses, and your contractor can explain them in more detail as if applicable to your particular situation. This was a fairly basic overview of a somewhat technical portion of the process, so just want to take a moment and see if there's any questions at this point.
Great, thanks, Stephen. So I'm checking the question box, and I don't see any questions right now, but just a reminder to the attendees, if you do have any questions, you can enter it into the question box.
Great, thanks. So beyond the is my building a good fit for solar question, there are a number of other things that we want to consider when thinking about installing a solar array on an apartment building. The first concept is something that Matt hit on a little bit earlier, and that's energy efficiency. One of the basic tenets of building science is that it is cheaper to conserve power than it is to generate it, whether that power is from a far-flung power plant or on top of your roof. Energy efficiency work is the building block for reducing a building's energy burden and associated energy cost. And solar can't be looked at it separately from that. In general terms, it will cost less to reduce your load and then install a smaller solar system to cover that reduced load than it will to install solar to cover your existing load. This is so important that many solar incentive programs around the country require some form of an energy audit at a minimum to identify those efficiency opportunities and take action on the most accessible ones. I don't believe any Oregon-specific programs have such a requirement at this time, but I would be very surprised if they were not added at some point in the future. The one that does concern us as affordable housing partners is that projects including solar and their low-income housing tax credit sources and uses, and actually even those that do not include it in their sources and uses, are required to improve their building's energy efficiency by a minimum of 10% over the existing conditions before you're allowed to monetize the tax credits. Competitive low-income housing tax credit applications may even have higher requirements as a function of their competitive applications. In fact, many other solar programs across the country require even higher improvement thresholds before allowing access to PV incentive funds, and for good reason. In order to develop the most cost-effective solar project, it is extremely important that you first reduce your on-site consumption through energy efficiency improvements before attempting to generate power on-site through a solar array. Net metering as a concept is really integral to understanding how grid-connected solar works. Net metering allows you to be credited for putting electricity onto the grid during instances when your generation exceeds your consumption, as well as being debited for drawing from the grid when your consumption exceeds your generation, and then to have the two netted out at the end of the year, with you being responsible for the remaining balance. In this image here, this shows the general steps of the path that sunlight takes before it turns into power and then enters into the grid. The important number here is number 4, which shows a bidirectional utility meter. This basically is a meter that spins forward and backwards and allows the utility to measure how much power you're putting into the grid versus how much power you're taking out of the grid. Virtual net metering takes this concept one step forward and is the ideal form of interconnection for apartment buildings by allowing an owner to install a single solar array with a single point of interconnection and then virtually divide and assign the solar benefit to all of the electrical accounts at the building, including tenant accounts. Without this, in order to provide a tenant benefit, each resident is essentially requires their own point of interconnection at their own meter, which generally drives the project cost up past the point of feasibility, or requires some type of master metering and clever billing structure to the residents. We will see one such example of this type of setup in the case studies at the end of the presentation. So it is doable, but it is more challenging. In this map from 2016, you can see that adoptions of this type of interconnection have been much slower and far less reaching than standard net metering interconnections I spoke of previously. I believe net energy metering is available in 46 of the 50 states currently. I do fully anticipate that in the coming years, more and more states and utility service territories will allow virtually net metered connections, as it really is the most viable way to implement PV in a multifamily building with tenant offsets. My understanding is that this is only available in Ashland's service territory, so we won't dwell on it for too long here, but know that if your building happens to be in one of the service territories where this is not available, you should make a point to let the utility and the Oregon Public Utilities Commission know that it's something for which there is a demand. You could contact the Oregon PUC and let them know that this is something that is needed to help drive multifamily PV, especially in the context of affordable housing. A multifamily solar system is generally broken into two parts. We have the owner energy load and the tenant energy load. Owners understandably want to offset and reduce their own costs first because it improves their bottom line and cash flow through reduced operational expenditures. In affordable housing, because increases in rents are typically restricted, it can be challenging to see a return on tenant systems because there are limited ways to recover those costs. Being able to leverage incentive programs to bring down the overall system costs are paramount to installing these types of tenant offsetting systems. For cost reasons in utility areas that do not allow virtually net metered interconnections, it can be extremely challenging to make the system pencil, even with a strong dose of financial incentives. That's if you want to provide energy benefit to your tenants. In areas that do allow virtually net metered connections, the typical approach is for the owner to fully offset their load and then to attribute any remaining production to the tenants through a virtual net metering agreement and some sort of square footage normalized distribution methodology. Do we have any questions about any of this or anything that we covered so far at this point?
Okay, I'm going to pause if there are questions just to give people a minute if they had any right now. Nothing came through since the last time we checked. Okay, I'm not seeing anything come through, so feel free to move on.
Okay. So now we'll talk about kind of the money side of everything. We've moved past the technical portion. We'll move on to the finance part because ultimately how we pay for these things is important to getting them done. So in addition to including solar in your LIHTC sources and uses and capitalizing the project that way, there are a number of other ways that we can help make PV more viable from a financial perspective, and we'll discuss some of those next. You really want to lean on the local programs that you have available to you. There are a great many city, county, and state incentives and policies that support renewable energy and energy efficiency in the United States, and Desire is the most comprehensive source of information on these incentives and policies. Established in 1995, Desire is operated by the North Carolina Clean Energy Technology Center at North Carolina State University and is funded by the U.S. Department of Energy. Desire stands for Database of State Incentives for Renewables and Efficiency. As you can see in this graphic, across the state of Oregon, there are 146 policies and incentive programs to help drive the installation and adoption of energy efficiency and renewable energy technologies across a wide band of buildings and use cases. By going to this site, you can easily see details about what types of incentives are available to customers in different utility service territories and municipalities. It is a fantastic resource, and I highly recommend that anyone interested in pursuing solar at their property look at this first to make sure that they aren't leaving any potential funding sources on the table. One of these local programs listed in the Desire database is Energy Trust of Oregon, who we referenced earlier. Energy Trust is an independent, nonprofit organization serving customers of Portland General Electric, Pacific Power, Northwest Natural, Cascade Natural Gas, and Avista. This service territory supports projects across Oregon and Southwest Washington. They provide solutions and cash incentives to lower energy costs, promote renewable energy, and support homes and businesses with energy efficiency. As mentioned before, the Energy Trust Solar Program has detailed guidelines and specifications for solar PV and solar-ready installations. Additionally, they are a great resource on finding reliable and trusted solar contractors to conduct the solar assessments and installations. Energy Trust offers their referral services to all interested parties, regardless of their location with the service territory. The most significant of the federal programs is the Solar Investment Tax Credit, colloquially known as the ITC. This is one of the most important federal policy mechanisms supporting the deployment of solar energy in the United States, and it continues to drive growth in industry and job creation across the country. Assuming you have sufficient tax liability, you can take tax credits equivalent to 30% of the total project cost. In large multifamily systems, that can translate to pretty large dollar amounts. Nonprofit entities likely won't have the tax liability to take advantage of this, and as a result, might want to consider third-party ownership options for their system where the nominal system owner can take that credit on the building owner's behalf and provide them some of the benefit rather than none of the benefit. We'll discuss some of those different ownership structures in a few slides. It is definitely worth noting that while the federal ITC is currently at 30%, it is scheduled to sunset and will tear down to 26% in 2020, then 22% in 2021, and then finally 10%. This may change with updated legislation, so keep your eye out for any updates or changes, but this is the current schedule. The system doesn't need to be installed this year to get the tax credit. You just have to have incurred the cost. So if the materials were purchased this year, you could install the system next year and still get the full 30% tax credit value. The next is a tax tool also. MACRS stands for Modified Accelerated Cost Recovery System. It's a method of depreciating the asset. It's an important tool for businesses to recover certain capital costs over the property's lifetime, allowing businesses to deduct the depreciable basis over 5 years reduces tax liability and accelerates the rate of return on a solar investment. This has also been a significant driver for the solar industry and other energy industries. Accelerated depreciation, along with other successful energy tax incentives such as the ITC, have really helped to fuel unprecedented growth in annual solar installations over recent years. Without involving politics, one of the positive outcomes of the recent tax bill as it relates to solar is the increase of bonus depreciation in the first year from 50% to 100%. If you also take the investment tax credit, you have to reduce your depreciation by half of that value. So in this case, it would be 15% for a total of 85%. As you can see in the table, the increase in bonus depreciation is a very powerful tool for improving the financials of a project like this. This table is a little dense, but it shows some of the different ways that you can approach the ownership structure of a solar project. They can be owned directly by a building owner or by a third party. each approach has relative merits and excels in certain scenarios. A PPA, or a power purchase agreement, is, you could think of it like a lease, where you're agreeing to purchase an agreed upon amount of power from the leaseholder. It's suitable for an entity with minimal capital to pay for the system up front, and typically requires little or no upfront investment by the building owner. A prepaid PPA construes many of the same benefits as direct ownership, but allows a nonprofit owner with capital and without tax liability to collect some of that value by having the nominal owner take that credit on their behalf. In both of these scenarios, maintenance is typically provided by the third-party owner. Direct ownership can potentially result in the best dollar-for-dollar financial outcome, but requires a significant capital expenditure up front, as well as having sufficient tax liability to take advantage of the various tax credits and programs. In this case, where there is no third-party owner providing maintenance, it's generally advisable to enter into some kind of maintenance contract. Like I was saying, you could think of a PPA like a lease, prepaid PPA like a prepaid lease, and a direct purchase is just giving someone money in exchange for a good. There are a plethora of resources for learning about solar. Here are a few of my favorite. We've already talked about the Desire database, but that's a free resource to find incentives and programs that support solar in Oregon and other states as well as energy efficiency and a host of other things. Solar Oregon is an organization that provides solar resources as well as hosts events. And PV Watts is an online tool that you can use to project PV system energy generation based off of any number of different site considerations. So you can enter your building address and then kind of play around with this tool to see how much energy you might be able to generate at your site. Lastly, I'm just going to review a couple of best practices, and then Matthew will take us home and present a case study of a couple of buildings in Oregon that have been able to implement large solar systems into their properties. So I'm just going to close my portion with that and some information that I've picked up over the years. This is a big one. If a tree falls in the woods and no one is around to notice it and then fix it, it will probably never get fixed. So you'll want to be able to proactively address any equipment issues by ensuring that your system comes with some form of monitoring and that it has the correct alarms set up to contact the correct person in the event of performance outside of the expected bounds. Because of the way third-party ownership agreements are typically structured, if you opt for that type of structure, it should come with monitoring in place. But if you opt for a direct purchase, you may need to inquire or pay an additional fee depending on the size or scope of your system. Without monitoring, unless you have a very engaged person looking at your utility accounts, you may not even realize that there's an issue for a long time until you get your true-up bill at the end of the year and realize that it's much larger than you would have anticipated. It's really hard to retroactively fix problems and get the solar benefit from them. Depending on the ownership structure of your system, it may or may not include a warranty beyond the required labor guarantee and equipment manufacturer warranties. If it doesn't, we generally recommend that one be purchased if available. Solar systems have an expected useful life of up to and actually beyond 25 years. So this thing is going to operate for a long time. And this is an important piece to ensure that your investment pays off long term and will carry you through that entire expected useful life. Shading from trees and soiling will reduce the productivity of your system. We generally try to avoid placing panels in areas that require ongoing tree trimming and maintenance, since that's one more long-term consideration that requires a human element and is ultimately hard to predict compliance with over the course of 25 years. Maybe your maintenance guide changes or whatever, but it's hard to really predict that tree is going to be maintained for 25 years. Sometimes it's unavoidable. So if this is the case, make sure that you have a plan in place to be able to maintain the projected tree trimming. Generally in wetter climates, such as the Pacific Northwest, rainfall is more than capable of cleaning the panels. But if your building is in a particularly dusty and dry area, you probably want to have a plan to at least wash the panels off at least once a year. There are services that can do this for you, or you can just use a low pressure garden hose to rinse them off. They're rated to be outdoors, so wouldn't worry about it. At the end of your project, it's really important to lean on your solar provider to explain the particulars of your system and what areas you need to pay attention to, and also to be aware of to ensure smooth long-term operation. Depending on who you hire, they may just tool off the job site, but you really want to lean on them to gather as much information about your system and its operations as possible before you let that resource leave. And with that, I'll transition back to Matthew, and he'll present us some case studies. And thanks.
Yeah, thank you, Stephen. That was great. As Stephen said, I'll close out the presentation with a local case study. So one of the organizations that we work closely with, Pacific Crest Affordable Housing, they strive to not only integrate efficiency into their projects, but they also have on-site energy generation through the installation of solar photovoltaics. The project team installing solar is not about just looking good in the public eye, which they do, of course, but it's instead about doing good for the tenants and ensuring that the addition of solar makes perfect economic sense in tandem with the efficiency measures. While Pacific Crest has grown to include large-scale solar PV systems on their buildings, that was not always the case. It was a result of a long process of learning how to maximize the PV system to give the best return to the building owner, and most importantly, the tenants. When beginning the building design process, the solar feasibility is always front of mind, which ensures the addition of the solar energy producing measures is cost competitive against other energy saving measures. Of these cost-effective measures, Pacific Crest has found solar to be of the best economic return amongst efficiency measures, such as increased attic insulation to R60, changing all the lighting to LED, Energy Star doors, and then reducing the building air infiltration. So they're targeting an ACH of 3.5. By purchasing the solar PV systems and generating electricity on site, Pacific Crest ensures that their buildings and tenants are protected from rising utility costs, which means that the tenants pay a base rental fee and are not burdened by a monthly utility fee. This is done by having the building be master metered and having the systems produced to offset all tenant consumption. So this is when Stephen was talking about the net metering laws, that we were operating under the standard net metering, and the whole building is producing and being offset what the consumption is. But each individual unit is still sub-metered so that they can perform an annual electricity consumption review to generate an average monthly energy consumption expectancy per unit with that specific tenant. So they have a few sites to highlight, but we'll start with the Little Deschutes Lodge. The Little Deschutes Lodge is located on La Pine, Oregon, and it's a 52-unit affordable housing community specifically for senior tenants. They have installed a 32.2 kilowatt PV system that is installed on carports, as you can see in their parking lot. This, is an added benefit to the tenants because it's shading their cars during the day, which it can get pretty hot in the Pine. And the Pacific Crest relies on these carports when there's not enough space on the roof. They found another way of doing it in the parking lot. Next, we have the Iron Horse Lodge, and it's located in Prineville, Oregon. It's a 26-unit affordable housing community, again for senior tenants. But this one has a 64 kilowatts of solar located on the large roof space that is reserved for solar. So you see that they didn't do carports on this one, and they put solar on the roof. You can also note, if you can see on there, on the far right, is their solar hot water system that helps offset the electrical consumption load from the hot water heating. Just recently, the Azimuth 315 was constructed, and this is in Bend, and it's a 50-unit, 47,000 square foot project that uses both solar carports and roof mounts to house their 106 kilowatts worth of solar. And if it isn't apparent before, the sequentials of these projects, they're getting bigger and bigger with their system sizes, and this is to meet the demands of their buildings, which are growing, and it's also balancing the changing demographic types, which have different energy consumption values. It's also, as they install more solar on their buildings, they get more and more experience, and they get better at balancing the financials of the installation. So their next project, and this one's actively going through the funding process, and they're recently awarded funding, and it will begin construction in the very near future. It's located in Bend again. It's a 43,000 square foot building with two 24-unit buildings. They're projecting, based off their energy modeling, that it'll be a 150 kilowatt system, so bigger than Azimuth 315, and they will be able to fit this whole system onto the two roofs of the two buildings. So they won't need any carports on this one. So they were intentionally designing the site layout and the building's orientation and roof design so they could effectively install the solar panels on the roof. So when it comes to having solar on your roof, you need to also take into consideration the tenant energy consumption. So the solar PV systems are designed based off of assumptions around baseline loads and occupant behaviors. However, Pacific Crest has experienced firsthand the difficulty of tenants over-consuming energy, which can throw off that balance of site production and cause the building to pull more energy from the grid than it is producing onto it. So when you have a building that's master metered, these additional utility costs would then fall on the building owners. To remedy this, Pacific Crest has come up with a way to monitor tenant behaviors without being overbearing or scolding, but rather to have the tenants understand the energy range that they should fall in, and then change their behaviors to accommodate. To add to this complexity, Pacific Crest found that units have an electricity range of approximately plus or minus 400% based off of the number of occupants and the occupant demographics per unit. So, like, would you believe that children and teens use much more water and electricity than adults? You know, those things all play into the factor of how much energy each unit's using. So previously, with their senior housing projects, Pacific Crest they found that they could use moral persuasion to encourage their tenants to reduce their loads. But now, with the expanded system sizes and diversity of tenants, Pacific Crest performs an annual review of tenant consumption through the sub-meter data to ensure that the tenant is aware of the range that is expected for their unit. If anything is abnormal, Pacific Crest performs a review and just talks with the tenant to see if anything has changed that would impact their annual electricity demand. Additionally, Pacific Crest has an occupancy guide that reviews all of the efficiency measures integrated within the building and how the tenant can strive to reduce their consumption and positively impact the building. In Pacific Crest, they've found that tenants are pretty responsive to this energy education approach, where they can see their data history and how they compare to the consumption of their neighbors. But really the key takeaway here is to have the occupancy guide so that tenants can reference the information regarding the building, the efficiency measures installed, and the source of the electricity, which in this case is coming from the solar on their roof. Pacific Crest has a great website with lots of information and some good videos about the work that they do. So feel free to visit this link and check it out for yourself. So with that, we'll open it up to questions and discussions for either myself or Stephen. So if you have anything, feel free to type it out in the questions box, or if you'd like to speak, just raise your hand in the GoToWebinar panel and we can unmute you.
Okay, we have a question that came earlier, and I'll just give folks a minute if they have any new questions to enter questions in the chat box, as well as Matthew mentioned, you can raise your hand and we can unmute you. So going back, Stephen, to the federal investment tax credit section, the question was, is that tax credit available for both existing properties and new construction?
Yes, the tax credit is available for both existing and new construction buildings. Any solar system that's installed, it'll be based on the installed cost of the system.
Okay, great. All right, so I'm just checking the question box. Not a question, but we've received a comment that said, thank you for sharing the case studies and especially the tenant education strategies. So thank you for that, and thank Pacific Crest Affordable Housing for allowing us to share that case study. Okay, I don't see any questions, so I'll just do a last call for questions, or if you want to raise your hand, we can unmute you. Okay, I will pass it off to Matthew to close it out.
Yeah, I just want to say thank you for attending. If you do have any comments or questions, feel free to follow up with either myself, Matthew, or Stephen. Our emails are on the final slide. And then again, you can go check out our the Multifamily Energy Program website, which is linked here. And make sure you sign up for the newsletter and attend any future webinars. Thank you again.
Great.
Cool. Thanks, everyone.